Okay, good afternoon to one and all. This is Gopi Krishna, Assistant Professor, Department of Computer Science and Engineering from Chevrolet Engineering College. Subject is compiler design. In previous class, we are going to discuss about what is the syntax directed definition and what are the types of attributes and what are the types of syntax directed definition. So first of all, what is syntax directed definition? So here, syntax directed definition means it is a combination of context-free grammar with semantic rules. That is called the syntax-directed definition. What are the types of attributes? So we are going to write the semantic rules with attributes are associated with grammar symbols and that semantic rules are associated with production. So that is the one point with the syntax directed definition. And what are the types of attributes we are having? Two types of attributes. First one is the synthesized attributes and second one is the inherited attributes. So what is synthesized attributes? It takes the values from the children's. Okay, so that is called the uh, synthesized attributes, and we are having the inherited attributes. We are taking the values from the parent and its sibling nodes. Okay, so that is called the inherited attributes, and we are having two types of syntax directed definition. First one is S S attributed syntax directed definition and L attributed syntax directed definition. So those are the types of syntax directed definition, and we are having to see one evaluation of expression for STD. We are seeing one example. So today's class we are going to discuss some examples of evaluation of expressions for STD and so the evaluation order for the STDs. Okay, so we are going to discuss today the some examples of evaluation of expressions and evaluation order for syntax directed definition. Okay, so here, so another example for this evaluation of expression of syntax directed definition. So what is the example for this one is syntax directed definition of a simple desk calculator or STD for evaluation of expression or annotated pass tree for 2 plus 3 into 4. So these three ways we are going to ask the question. Okay, so this is the example we are constructing annotated pass tree for the given expression 2 plus 3 into 4. Okay, so in this one we are having some productions as well as semantic rules. So here, based on the expression we are going to write the productions. So మీకు ప్రొడక్షన్స్ ఇవ్వలేదనుకోండి బేస్డ్ ఆన్ ఎక్స్ప్రెషన్ వీఆర్ గోయింగ్ టు రైట్ ద ప్రొడక్షన్స్ సో బేస్డ్ ఆన్ ప్రొడక్షన్స్ వీఆర్ గోయింగ్ టు రైట్ సిమాంటిక్ రూల్స్ ఓకే ఒక్కొక్కసారి సింపుల్ ఎక్స్ప్రెషన్స్ ఉన్నాయనుకోండి వాళ్ళే ప్రొడక్షన్స్ ఏమి ఇవ్వరు సో బేస్డ్ ఆన్ దిస్ వన్ సో ఇన్ దిస్ ఎక్స్ప్రెషన్ వీఆర్ హ్యావింగ్ ప్లస్ అండ్ స్టార్ సో బేసిక్ ఎగ్జాంపుల్ ఫర్ ఈ ఈజ్ ప్రొడ్యూస్డ్ విత్ ఈ ప్లస్ టీ is produced with T and T is produced with T star F and T produced with F and F produce digit. So these productions we are going to use. Okay. So what is the semantic rules? E dot value is equals to E dot value plus T dot value. And here E dot value is equal to T dot value. T produces T dot F. So T dot value is equal to T dot value into F dot value, and T dot value is produced with F dot value, and F produced with digit. So we are writing semantic rule is F dot value is equal to digit dot lex value. Okay, so we are going to write the productions and semantic rules. So in our parse tree, we are constructing annotated parse tree for some other expression, so that the expression is difficult. So at question paper, we are going to write. We are having some productions and as well as the semantic rules is there. Okay, so that is another way. So here we are going to write. So ఇక్కడ మనకి productions ఇచ్చారు, semantic rules ఇచ్చారు. So by using these productions and semantic rules, we have to construct the annotated parse tree for 2 plus 3 into 4. Okay, so first of all we are going to write the annotated parse tree. So first we are construct the parse tree. So we are constructing the parse tree. We are having the first production. So E produces E plus T. What is the first production here? E produces E plus T. So E1 plus T means so this E and this E is same, but we are having some difference. We have to show some difference. Then we are writing E produces E1 plus T. But we are constructing the parse tree. There is no difference with E with E. So we are writing just E and E in the past. But the productions we are showing some difference. We are writing E produces E1 plus T and T produces T1 star F. So, but there is no difference in this one. Okay, we are showing the difference in that particular production. We are writing E produces E1. Okay, in that past tree there is no difference. E produces E plus T. So, what is the first production here? E produces E plus T, right? E produces E plus T. So we are constructing the past tree. So first one, E produces E plus T. So that is the first one. And here in previous example, we are having 2 star 3 plus 4. Okay, in previous example, we are having 2 star 3 plus 4. Okay, so in this example, 2 plus 3 star 4. So here we are having plus. So plus వచ్చేసింది. Then we are converting this t based on the expression we are constructing the parse tree. So expression బేస్ చేసుకొని మనం parse tree ని కన్స్ట్రక్ట్ చేయాలి. సో అదే ఇక్కడ ప్లస్ ఉందని ఇక్కడ స్టార్ ఉందనుకోండి ప్లస్ ప్లేస్ లో. సో దెన్ వీఆర్ ఎవాల్యుయేటింగ్ ఈ దిస్ ఈ వీఆర్ కన్వర్టింగ్ ఇట్ టీ and t is converting t star f. So in this way, in this expression, plus is available at the starting. Then no need to convert this e. And we are having 3 star 4, then we are converting this t into 3 star f. So here e is converting, so e produces with t. So we are converting e with t and t with f, f with digit dot lex value. Okay, then plus, so this t is converting t star f. So this t is converting t produces f and f produces digit, and this f is converting digit dot lex. So this is the construction of a parse tree. Okay, so we are constructing the parse tree. Then we are going to convert this parse tree into annotated parse tree. So what is annotated parse tree? So a parse tree which contains the values at each node. So values అనేవి ప్రతి ఒక్క నోడ్ దగ్గర మనకి present అయి ఉంటే that parse tree is treated as a annotated parse tree. Okay, so before going to construct a annotated parse tree, so parse tree is E produces E plus T, and this E with T, this T with F, and this F with digit, and this star is having 3 star f, and this t is f and digit f is produced with digit. So we are constructing this parse tree to annotated parse tree. So we are going to convert a parse tree with annotated parse tree by using a traversal from top to bottom and left to right. So if there is any reduction in that parse tree, so we need to perform the corresponding semantic action. Okay, we need to perform the semantic action. Okay, so here we are going to convert this syntax, this parse tree with annotated parse tree by taking the traversal from top to bottom. Okay, so here we are going to convert. So this digit dot lex value is equals to, we are writing, so first value is digit is 2, then we are placing, and this, so this is 2 plus 3 and star 4. So this is, we are writing 2, 3, 4 with digit values. Then now we are converting this one as a annotated parse tree. So what is the annotated parse tree? A parse tree which contains values at each node is known as the annotated parse tree. Then we are writing this we are converting this parse tree to annotated parse tree. by using the traversal from top to bottom and left to right. So here we are using this one. So here first one, digit dot lex value is equals to 2. Then we are moving. So digit dot lex dot value is converting with we are converting the production. So f produces digit. Okay. So if there is any reduction, so we are converting a parse tree with annotated parse tree. If we are having any reduction, then we want to um, perform a semantic action. Okay. So here we are going to perform the semantic. So here is the reduction. So we want to perform the semantic action. So this is the f produces digit. Then f dot value is equal to digit dot lex value. So what is the digit dot lex value? So it is converting the with so semantic action. So f dot value is equals to em rastaru. F dot value is equals to digit dot lex dot value. So what is the value of digit dot lex value? That is 2. So we are placing 2 here. Then we are moving top to bottom and left to right. So here we are moving upwards. So f dot value is equal to 2. So here is a another reduction. Then we want to replace that one with a semantic action. So what is the semantic action? So t star f. So we have a production t star f. Then t dot value is equals to f dot value. What is the value of f dot value? It is 2. So we are replacing t dot value is equals to f dot value, that is 2. We are replacing 2 here, and here we are having one more reduction. Then we want to replace the corresponding semantic action. So here we are using e produces T. So what is the production? E produces T. So what is the semantic action? E dot value is equals to T dot value. So then T dot value is 2. Then here E dot value is equals to T dot value. So what is the value of T dot value? That is 2. We are replacing 2 here. Then here, then plus, there is no reduction. So then we are getting T dot value here. So we are considering E produces E plus T, but T dot value is not given in this one. So T dot value we are occurring to bottom. So then we are going to write here we are moving downwards. So left to right. So here we are again moving to downwards. So here digit dot lex value is equal to 3. Then here also one reduction we are moving, we are going to perform. So one semantic action. So f dot value is equals to digit dot lex value. So that is 3. We are placing 3 here. And this one again we are having one reduction. Then we are going to use corresponding semantic action. So T produces f. So T produces f. Then T dot value is equals to f dot value. What is the value of f dot value? 3. Then we are replacing this one. Then again star. There is no reduction. Again we are having downwards. So digit dot lex value is equals to 4. Digit dot lex dot value is equals to 4. Then so digit dot lex dot value is equals to 4. So here we have a reduction. Then we are having f dot value is equals to digit dot lex value. Then what is the value of digit dot lex dot value? That is 4. So we are placing 4. Then in this one we are moving upwards. So here T star F. So we are having the reduction here. So T star F. So what is the production here? T produces T1 star F. So here T produces T1 star F. So in this part we are having both this T and this T are equal. Okay. Then so T dot value is equal to 3 star F dot value. So what is the reduction here? So T produces T star F. What is the semantic rule we are using? T dot value is equals to T1 dot value into F dot value. What is the T1 dot value? That is 3. And what is the F dot value? 4. So 3 into 4, 12. So we are replacing T dot value with 12 and again moving upwards. So here we are having one more reduction. So E produces E plus T. So E produces E plus T. What is the semantic rule? E dot value is equals to E1 dot value plus T dot value. So what is the value of E dot E1 dot value? So that is 2, and what is the T dot value? That is 12. Then what is the value of E dot value? So 2 plus 12, that is 14. So here we are having the final result. So what is the pass tree? So we are constructing a pass tree with a um, given expression, and that pass tree we can convert it with annotated pass tree. So what is annotated pass tree? A pass tree which contains the values at each node, that is called the annotated pass tree. So in this annotated pass tree, so first we are having, so this is one node, and this is another node, this is another, this is another, and this one. So we are having the nodes. So each node we are having a value. So here 2, and here 2, and here 2, and here 2, and 3, 3, 3. So each node we are having some value. So that is called the annotated path tree. So we are converting a path tree with annotated path tree by specifying the values for that particular node. So by if there is a reduction, then we are perform the corresponding semantic action. Okay. So reduction అనేది వస్తే ఆ పర్టికులర్ రిడక్షన్ ని మనం ఆ రిడక్షన్ కి సిమాంటిక్ యాక్షన్ అనేది అప్లై చేస్తాము. ఓకే. సో దిస్ ఈస్ ద another example of given expression. So this is the evaluation of expression for syntax directed definition. So what is syntax directed definition? So this is the syntax directed definition. So we are having some productions and we are having some semantic rules. This total is known as syntax directed definition. So this definition, so far we are evaluating of some expression 2 plus 3 into 4. So this is the example for construction of a or evaluation of expression or construction of annotated path tree for the expression. Okay. So is there any doubt with this one? Any doubt? సో ప్రొడక్షన్స్ సిమాంటిక్ రూల్స్ ఒకవేళ వాళ్ళే ఇస్తారు, వాళ్ళు ఇవ్వకపోతే మన బేస్డ్ ఆన్ ద ఎక్స్ప్రెషన్ వీఆర్ గోయింగ్ టు కన్స్ట్రక్ట్ దిస్ ప్రొడక్షన్. ఓకేనా? సో ఇవే తీసుకోవాలనే రూల్ ఏం లేదు, మనకి బేస్డ్ ఆన్ ఆపరేటర్స్ వీఆర్ యూజింగ్ సమ్ ప్రొడక్షన్స్. ఓకే. దెన్ నెక్స్ట్ వన్ another example. So SDD for simple type declaration. Okay. So syntax directed definition for simple type declaration. So type declarations ని ఎలా యూజ్ చేస్తారు అనేది ఇస్తున్నారు. సో ప్రొడక్షన్స్ వాళ్ళే ఇచ్చారు, సిమాంటిక్ రూల్స్ కూడా వాళ్ళే ఇచ్చారు. ఓకే. సో వాట్ ఆర్ ద ప్రొడక్షన్స్ హియర్? D produces P, L, and T produces int, and D produces float, and L produces L comma ID. L comma ID. So we are showing some difference with this L and this L. We are specifying L1. Okay. And L produces ID. So these are the productions. Okay. So what are the semantic rules for these productions? Here L dot INH. INH means inherited attributes. So what is the inherited attributes? What is inherited attribute? Anyone? Hello? Anyone? What is the inherited attributes and what is synthesized attributes? Boys or girls? Anyone can respond? No one? Okay. So what is synthesized attributes means in this we are taking the values from their children. That is called the synthesized attributes. And what is inherited attributes? We are taking the values from its parent as well or siblings. That is called the inherited attributes. So that is semantic inherited attributes as well as semantic attributes. So here we are using L dot inherited is equals to T dot type. So that means so here L dot inherited means so we are considering this one. So we are taking the value with this sibling T dot type value. So that is the L dot inherited is equal to T dot type. So T dot type means the value of T. So that is the sibling value. So here L dot inherited equals to T dot type and T produces int. So T dot type is equals to int and T produces float and T dot type is equals to float and L produces L1 comma ID. So here L1 dot inherited equals to L dot inherited. So here L dot inherited value ni L1 dot inherited ki assign చేస్తున్నాం and L produces ID. So this is the add type of ID entry L dot inherited. Okay, so this is the semantic rules for the given production. Okay, so which are so we have to construct the annotated pass tree for int comma int a comma b comma c. So this is the given input string. So int a comma b comma c. Okay, so we are constructing a annotated pass tree for this string, that is int a comma b comma c. Okay, so what is annotated pass tree? A pass tree which contains values at each node is known as annotated pass tree. Okay, then we are constructing first pass tree, then that pass tree we are converting into annotated pass tree. Okay, so here we are constructing the pass tree for this given production. So what is the first production in this one? So the production is D produces TL. So we are considering the first production, we have to construct the pass tree. Okay, so here D produces TL. So we are having TL. Then what is the input string? Int a comma b comma c. So TL. Okay. So we are having T produce. We are having two productions with capital T. So T is a non-terminal. We are having two productions with capital T. Then T produces int and D produces float. So in this given expression, so what is the type? What is the data type here? Int. So if there is having float, then we are considering this production. So he in this expression we are having integer, then we are considering this one. So here T produces int, then this one L capital L. So in this capital L we are having two productions. So L produces L1 comma ID and L produces ID. So we are having L produces ID. Let us consider L produces ID. So L produces ID. So we are stopping there. Okay. So this is not a correct production. Okay. Why? Because in our expression we are having three identifiers. So one identifier is A and another identifier is B and another identifier is C. Then we are considering the production L produces L1 comma ID. So here L produces L1 comma ID. Then again L produces. So here we are having two productions with L produces L1 comma ID and L produces ID. So we are having we are considering this one. We are considering this one. So L produces L1 comma ID. So we are having three identifiers. Then we are taking this production. So this production is considering we are getting two identifiers. So in our expression we are having three identifiers, then we need to consider this production here. So L produces L1 comma ID. So again L is pass tree L1 comma ID. And finally we are taking ID as the production. So this is the given pass tree. So D produces TL and T produces int and L produces L comma ID and again L produces L comma ID and again L produces ID. So this is the pass tree. Then we want to convert this pass tree into annotated parse tree. So what is annotated parse tree? So uh, a parse tree which contains the values at each node, that is called the annotated parse tree. So here we are having, so we want to convert a parse tree into annotated parse tree, then we are considering top to bottom and left to right traversal. Okay, so in this traversal we are having any reduction, then we need to replace that reduction with corresponding semantic action. Okay, then here D produces, so in this one we are moving top to down, and we are moving to this one here int. So integer, so we are having some production with T produces int, then there is a reduction here, then we are converting this one with semantic action is T dot type is equals to int. So here T dot type is equals to int, we are specifying. So we are moving top to down and left to right. So here moving this one. So why? Because so in previous example we are moving top to down and left to right. So here we are moving downwards, right, in previous example. Now consider this example, we are moving right with L inherited. So what is inherited attribute value? So we are taking the values from parent node or sibling nodes. So here we are considering this one. So D produces T L. So what is the production here? D produces TL. We are considering this one. So what is the semantic rule? So here is a reduction. Why? Because D produces, so T dot type is equals to int and L is equals to sum. D produces T L. We are having the production. So why? Because here is inherited attributes. Then we are taking the values from parent node or sibling node. So we are considering this production. So the semantic rule is L dot inherited is equals to T dot type. So T dot type means here the sibling node is T, then we are considering this product, this one. So T dot type is equals to int, then L dot inherited is equals to T dot type. Then what is the T dot type value? Int. So we are specifying the int. Then we are moving downwards. Okay. So again we are moving downwards. Here we are having L dot inherited. Okay. So in this one L dot inherited L dot inherited is equals to int. So how to get this one? So here also we are having the production. So L produces L comma id. L produces L comma id. So here is the production. What is the corresponding semantic rule? So here we are having the reduction here. Then we want to replace the corresponding semantic action. So L produces L comma id. So what is the production? L1 dot inherited equals to L dot inherited. So what is the parent value here? So here is the parent. So L is the parent and L1 is the child. So L1 comma id is the child for parent L. Then what is the production? Semantic rule L1 dot inherited equals to L dot inherited. So L dot inherited means it is a parent value. So we are taking the inherited attributes means we are taking the values from parent or siblings. So here we are taking the sibling value. We are considering this one, we are taking the parent value. So what is the parent value here? Int. So we are specifying the int here. Then we are moving downwards, and here also one reduction. So L produces L comma id. L produces L comma id. So in this one, so we are using this semantic action. So L1 dot inherited equals to L dot inherited. So the parent for this one is L dot inherited. Then we are having the int. So we are specifying the int. Then coming to downwards id. So there is no reduction, and moving right, the here also id, and here also id. So there is no reduction here, so we can stop here. So we are converting this pass tree with into annotated pass tree. So we are having the all the uh, all all nodes with some values. So that is called the annotated pass tree. Is there any doubt with this one? So we are getting int a comma b. So here int space int a comma b comma c. That is the given expression. Okay. So we are constructing that one. So this is the annotated past. Is there any doubt? So okay, next one. So here we are having some grammar. So syntax directed definition for a grammar. So here is the production. The production is T produces F T dash. So here we are having two semantic rules. So first one, T dash dot inherited equals to F dot value, and T dash dot value is equals to T dot synthesize. So SYN means synthesized attributes, and INH means inherited attributes. So next to production, T dash produces star F T 1 dash. So T dash and T1 dash both are same. We are showing the difference. So we are placing T1 dash. We are constructing a pass tree. Then we are specifying only T dash only. Okay. So here T1 dash dot inherited equals to T T dash inherited into F dot value, and T dash dot synthesized equals to T1 dash synthesized, and T dash produces epsilon. So T dash dot synthesized equals to T dash dot inherited, and F dot digit is equals to F dot value is equals to digit dot lex value. So these are the productions and these are the semantic rules. So this total we are considering as a syntax directed definition. Then we are now going to construct a enumerated pass tree for the expression 3 star 5. Okay. So what is enumerated pass tree? A pass tree which contains values at each node is known as the annotated path. So what is synthesized attribute? If a node takes a value from its children, and what is inherited attribute? If a node takes a value from its parent or sibling node. So these are the two attributes, synthesized attributes and inherited attributes. Now we are constructing a path tree for this productions, and then we are converting the sparse tree into annotated sparse tree. So what is the first production here? T produces F T dash. Okay. So we are considering T produces F T dash. So T with F T dash. So in this how many semantic rules here? Two semantic rules. Then we are having T dot T dash dot inherited and T dash dot synthesis. Okay. And here F. So F produces digit directly. So F produces digit. Why? Because the expression is T star 5. So here 3 we are specifying, and this T dash dot inherited or T dash dot synthesized. So how to convert this one? So T dash we are having two productions. So here T dash is star F T1 dash, and T dash produces epsilon. So we are using T dash produces epsilon. Then what is our expression? 3 star 5. So this is star 5 not getting for we are considering T dash produces epsilon. Then that's why we are going to taking T dash produces star F T1 dash. So here T dash produces star F T1 dash. Okay. So in this T1 dash we are using again two semantic rules. Then we are writing T dash inherited and T dash synthesized. Okay. Then this F is converting digit. Okay. Finally, this is 3 and star, this is 5, and star into, so here T dash we are going to write with epsilon. Then So 5 into epsilon becomes 5 only. So we are considering this expression. Okay. So it is the parse tree. Then now we are going to construct a annotated parse tree for this parse tree. Okay. So we are going to traversal from top to bottom to left to right. If they if there is any reduction, then we want to replace that particular value with some semantic corresponding semantic action. Okay, so here top to bottom. Okay, and left to right. So here we are having the reduction digit dot lex dot value is equal to 3, and the production is f produces digit. So f produces digit. Then we are having the reduction. Then we are going to replace semantic action is f dot value is equals to digit dot lex value. So what is the digit dot lex value? 3. So then it is replacing with f dot value is equals to 3. Then we are moving here. Here we are having inherited attribute. So we are considering this one. Okay. So T dash, we are considering this production. T produces F T dash. So T produces F T dash. So we are considering this one. So we are having two semantic rules. Then what is two semantic rules? T dash dot inherited is equals to F dot value. So here T dash with sibling is F. Then we are replacing F dot value with T inherited. So what is the sibling value? F dot value is equal to 3. Here we are writing T dash dot inherited is equal to 3. So this F dot value we are placing this one. Now what is T dash dot synthesized? So there is no value for us. So T dash dot synthesizes. T dash dot value is equals to T dash dot synthesize. So we are getting T dash dot synthesizing. So there is no reduction here. So we are moving downwards. So we are star. There is no reduction, and we are moving right, and here we are reduction digit dot lex dot value is equals to 5. So we are having a production f produces digit. Then we are digit dot lex. So f dot value is equals to 5 we are placing. Then we are moving this one. So here we are having T dash dot inherited. Okay. So and we are having T dash dot synthesized. So what is the production here? T dash produces star F T dash. So the production is T dash produces star F T dash. So here we are two semantic rules. So first one T1 dash. So this is the T1 dash. So T1 dash dot inherited is equals to T dot inherited. So what is the value of T dot inherited? So T dot T dash means it is a parent value. So in this one we are, what is the parent here? This one. So T dash dot inherited. What is the value of here? 3, and into f dot value. So f dot value is a sibling value. So what is the value of sibling here? F dot value is 5. So 3 into 5. What is the value of 3 into 5? We are getting 15. So we are specifying 15 here. Then next one T dash. So we are moving downward. So epsilon. So here T dash produces epsilon. So here we are having reduction, then we are placing T dash dot synthesized attribute is equals to T dash dot inherited. So what is the T dash dot inherited value? So that is 15. So that T dash dot synthesized is equals to T dash inherited. So this is 15. This is 15 is assigned to this one. So here T dash dot synthesis equals to 50. Again we are moving upward. So here there is no value here. Why? Because we are not finding T dash dot synthesized. So here we are having the reduction. So T dash produces star F T dash. Okay. So T dash T dash produces star F T dash. So this is the production here. So T dash dot synthesis is equal to T1 dot synthesize. So what is the value of T1 dot synthesized value? 15. So this value is assigned to T dash synthesizing. So here 15. Then we are moving upwards. So what is the production here? T produces F T dash. So what is the production? T produces F T dash. So this is completed, and T dash dot value is equals to T dash dot synthesized. What is the value of T dash dot synthesized? That is 15. So T dot value is equals to 15. We are assigning here. So here, sorry. So here 15. So this value is assigned to T dot value is equal to 15. So this is the reduction. So this is the production, and this one is the corresponding semantic action. So finally T dot value is equals to T dash synthesized. So that is 15. We are specifying 15 here. So this is the conversion of pass tree into annotated pass tree. Okay. Is there any doubt with this example? No one? Next, right. Next one, evaluation order for syntax directed definition. So in previous we are going to discuss evaluation of an expression, or we are constructing annotated pass-through. So evaluation order for syntax directed definitions. So we are using dependency graph. Okay. సో ఎవాల్యూషన్ ఆర్డర్ అంటే ఎవాల్యూషన్ అనేది ఏ ఆర్డర్ లో జరుగుతుంది అంటే ఫస్ట్ ఏ స్టెప్ ఎగ్జిక్యూట్ అవుతుంది, దెన్ నెక్స్ట్ ఏ స్టెప్ ఎగ్జిక్యూట్ అవుతుంది. సో వీఆర్ నేమింగ్ ద సమ్ ఆర్డర్. సో దట్ ఈస్ ద evaluation order for syntax directed definition. So in order to determine evaluation order for the attribute instances in a given pass tree. సో ఇచ్చిన పాస్ ట్రీకి మనం ఒక ఎవాల్యూషన్ ఆర్డర్ కనుక రాయాలి అనుకుంటే బై యూజింగ్ డిపెండెన్సీ గ్రాఫ్. ఓకే, బై యూజింగ్ డిపెండెన్సీ graph. So what are the advantages of dependency graph? So here we are having three advantages. So first one is dependency graph represents the flow of information. So ఈ డిపెండెన్సీ గ్రాఫ్ ఏం చేస్తుందంటే ఫ్లో ఆఫ్ ఇన్ఫర్మేషన్ అనేది ఎలా జరుగుతుంది అట్రిబ్యూట్స్ మధ్యలో. సో దట్ డిపెండెన్సీ గ్రాఫ్ రిప్రజెంట్స్ సో ద ఫ్లో ఆఫ్ ఇన్ఫర్మేషన్ అమాంగ్ ద అట్రిబ్యూట్స్. ఓకే, that is the one advantage. And second one, dependency graphs are useful for determining evaluation order for attributes. So already చెప్పాను కదా evaluation order కి మనం ఈ dependency graph ని యూజ్ చేస్తున్నాం. So that is the one of the advantage in a dependency graph. So we are determining the evaluation order. Okay, next third one, while an annotated pass tree stores the values of attributes. అంటే annotated pass tree ఏం చేస్తుంది, what is the meaning of, what is the definition of annotated pass tree? So a pass tree which contains the values at each node, that is called the annotated pass tree. So here while an annotated pass tree shows the values of attributes, a dependency graph determines how those values can be computed. సో ఆ వాల్యూస్ అనేవి ఎలా వచ్చినాయో మనం తెలుసుకోవడానికి ఈ డిపెండెన్సీ గ్రాఫ్ అనేది యూజ్ అవుతుంది. సో ఇన్ ప్రీవియస్ ఎగ్జాంపులే మీరు ఆల్రెడీ చేసిన ఎగ్జాంపుల్. సో ద ప్రొడక్షన్స్ ఆర్ ఈ ప్రొడ్యూసెస్ E1 ప్లస్ టీ, E produces T, and T produces T1 star F, and T produces F, and F produces digit. Okay, what is the semantic rules? E dot value is equal to E1 dot value plus T dot value. E dot value is equal to T dot value. T dot value is equal to T1 dot value into F dot value, and T dot value is equal to F dot value, and F dot value is equals to digit dot LECT value. So here is the expression. Already we are specifying 5 plus 3 star 4. Okay, then we are constructing a pass tree and annotated pass tree, then evaluation order of syntax directed definition. Okay, so this is the pass tree. So what is the first expression? E produces E plus 3. What is the expression here? 5 plus 3 star 4. Okay, so E produces E plus T. So here we are having E produces T and T produces F, and digit dot LECT value is 5. Why? Because so this E is not performing any multiplication. So we are having addition is first. So expression 5 plus 3 star 4. Then this T is replacing with a star. So T produces T star F. So this T is replacing f, and f is replacing digit dot lex dot value, and this f is having digit. Okay, so digit dot lex dot value. So that is here 5, 3 star. So 5 plus 3 star 4. So this is the corresponding parse tree for the given grammar with semantic rules. So what is annotated parse tree? So we are using annotated parse tree from top to bottom and left to right. So already we are constructing annotated parse tree from top to down and left to right. So first this one is replacing f dot value, and this f dot value is replacing t dot value, and t dot value is replacing e dot value. Then we are moving here. So t dot value is not getting. So then only we are moving to down, and this one f dot value is replacing digit. So this one is replaced with this one and star. Again we are moving. So finally t dot value. So t star f. So t star f. So manaki 3 into 4, that is 12. Finally 5 plus 17. So this is the annotated parse tree. So what is the dependency graph for the annotated parse tree? So here we are having the parse tree and annotated parse tree. So dependency graph means we are specifying the order of execution. So ఆ వాల్యూ అనేది ఎలా వస్తుందో చెప్పడానికి మనం యూజ్ చేస్తాం. సో ఈ annotated parse tree లో మనం ఫస్ట్ రిడక్షన్ వస్తే రీప్లేస్ చేసింది ఏంటిది? ఇదే కదా. సో దట్స్ వై వీఆర్ స్పెసిఫైయింగ్ 1, second, third, fourth, then we are moving down and 4 అయిపోయింది. Next one 5, 6, 7, we are moving right, then down 8, 9, 10, 11. So this is the dependency graph. That means we are computing the values. So what is the third advantage of dependency graph? So while an annotated parse tree stores the values of attributes, a dependency graph determines how those values can be computed. So ఆ values అనేది ఎలా వచ్చినాయో చెప్తా ఉంటుంది. సో ఇక్కడ 5 ఉంది, ఈ 5 ఇక్కడికి ఎలా వచ్చింది? సో దిస్ ఈస్ ద వాల్యూ కంప్యూట్. సో కంప్యూట్ అనేది ఎలా జరిగింది? సో దాని యొక్క ఆర్డర్ అనేది స్పెసిఫై చేస్తాం కాబట్టి దీన్ని డిపెండెన్సీ గ్రాఫ్ అన్నారు. సో ఎవాల్యూషన్ ఆర్డర్ ఫర్ SDD by using dependency graph. Okay, is there any doubt with this dependency graph? Anyone? Boys? Hello? Hello?
No, sir.